Greetings and welcome, ladies and gentlemen. Today we're talking about synthetic division. Now you've learned how to do long division of polynomials. However, synthetic division will be an alternative, which is somewhat easier. However, it does have its limitations. It turns out synthetic division only works, ready, catch this, when you're dividing by a linear, let's see, I don't like the way that linear came out, linear binomial that has a leading coefficient of 1. Lots of math words in this limitation here. Lots of them. So, let's do an example here. Bam. So I'm going to have x squared minus 10x plus 16. And I'm going to divide that by x minus 2. Okay. And let's consider, does this fulfill our requirements? What? Binomial. Yeah. So let's see. What am I dividing by? I'm dividing by this. Let's see. Is what I'm dividing by linear? How do I know? What's its degree?
1.
1. There's a little invisible 1 there, and that's linear. So it meets that requirement. Is it a binomial? What does binomial mean? Two terms. All right, so I've got 2 terms here. So it's a binomial. And is its leading coefficient 1? What's the leading coefficient? Where's the leading coefficient, in fact? In front of the x. And there's an invisible 1 there. So this appears to meet all of my requirements for synthetic division. So here we go. Check this out. For synthetic division, this is our setup. It's different than what we're used to. I'm going to put a little box, half a box, I guess, like that. I'm going to leave room for a row of numbers here. I'm going to skip a line and actually write this line here. All right, so it's kind of a weird setup, but that's what we do. Now the number that goes in the box, I'll put a little number in here, is going to be the opposite of this. So it's going to be a positive 2. Opposite of my constant.
So is it the 7 term of the binomial?
Yeah, it'll be the opposite of my constant within my binomial that I'm dividing by. Yeah.
It's always a constant.
Yep. So, opposite. Now, the numbers that go in this row here are going to be my coefficients of this guy. Okay? All right, so here we go, friends. So what number, what's the coefficient of my x squared term? 1. What's the coefficient of my linear term? Negative 10. And what's the coefficient of my constant? Or, well, I guess it's not a coefficient, is it? 16. All right, so I've merely translated those here. And if, for some reason, I had, say, the need of a placeholder, what number do you think I would write?
1. 0.
0, right, is what I would write. You guys got it. So, now catch this. We got the setup here. Now, synthetic division is a 2-step process that's repeated over and over, similar to how long division was 4 steps repeated over and over. Instead of divide, multiply, subtract, bring down, I'm going to do 2 steps. I'm going to add, I'm going to multiply, repeat. So it's nice and easy. So the first thing I'm going to do, I'm going to add this column. So 1 plus nothing is 1. Okay, so that was the add step. Next step, multiply. I'm going to multiply my box by that and write it over here. Takes a little while to get used to, but you'll be surprised. This will be super awesome when you're awesome at it. Yeah, that makes sense. Sure. So, so 2 times 1 is 2. Now I'm back on the add step. Negative 10 plus 2? Negative 8, correct. Now I'm on the multiply step again, so I'm going to multiply 2 times negative 8 and write my answer there. So that's negative 16. And now I'm on the add step, and I get 0. So my answer is, 100 negative 80. No, that's not it. I'm going to have to translate this answer back into polynomial speak. And in order to do that, I'll have to know what each of these coefficients or digits mean. The rightmost digit is always going to be your remainder. And then I actually like to go from right to left when I do this, and you'll be very unlikely to get this wrong. So the next one over to the left will be your constant. The next one over will be our linear term. So that's I've got 1x. And that's all I had, so this would be my answer. So x minus 8 is my answer.
Wait, 1 is your linear term?
Yeah. And then if I had another number here, that would have been like 2x squared. Or, all right. And as you keep going to the left, it's just one exponent higher than the one before it. So, that's the general setup for synthetic division. It's kind of weird, but it's cool. It's cool.
Yeah.
What's the difference with long division?
Yeah, it'll give us the same answer that long division would have,
Yeah.
but it's faster. And actually, eventually, I'll even eliminate half of the work we do, and we'll be even quicker at it.
Okay.
So we're going to be super good at this. Super good.
So why didn't you teach us this first?
Because you already knew long division. And this one's also limited. This one only works in a very particular case. Where long division, I could divide by a trinomial if I want. And it doesn't matter what the leading coefficient is. And it doesn't matter if it's like a x to the 5th degree or whatever. So long division is beefier. It's kind of a process that works, in all situations. But synthetic division, when you can use it, man, you want to use it. So here we go. Let's say I've got this problem. What if I've got 3x cubed? Let's do cubed. How about 3x cubed plus 2x squared, and then I'll do minus 5. And I want to divide this by divide by x, and we'll do plus 1. Boop, doop, doop, boop, doop, boop, boop, doop, boop, boop, doop, boop, boop. Here we go. So what's going in the box? Negative 1. It's opposite. It's not enough to look like Squidward. You gotta act like him too, right? Opposite. So let's see, and then what numbers are going here? My placeholders? Nope, my coefficients.
3, 2, 0,
Ooh, 3, 2, 0, negative 5. I like it. Why is the 0 there, friend?
It's because it's got a placeholder.
Hmm.
Or the x.
Yeah, my highest degree was 3, so I need 3, 2, oh, I didn't have an x to the first, so that's why I have 0 of them, and then x to the 0ths for my constant, right? So placeholders still matter. Still matter. So let's do this. Okay, I'm going to use the colors for one last time here. So let's do this. Add, multiply. So add this column. 3 plus nothing is 3. Multiply. Negative 1 times 3 is negative 3. And then we'll add. All right, I can only change colors so fast here. 2 and negative 3 is negative 1, right? Negative 3 is more influential. And then we'll multiply. Positivo uno. And then I'll add. And then that's 1. Okay, we're doing it. And then I'll multiply -1. And then I add.
-4.
Negative
Oh, you're
6,
adding.
because I'm adding. So don't get thrown off by that old subtract step from long division, right? Remember, this is add, multiply, AM, repeat. AM. Yeah, there we go. So let's translate this to an answer, polynomial style. So my remainder is -6. Then I have got +1 as my constant. I've got -1x, or just minus x as my linear term. And 3, positive 3x squared will be my quadratic term. So I could write this as 3x squared minus x plus 1 minus 6 over what?
6 over
X plus 1. Well done. Well done, well done. Right? So, I mean, it's not that bad. You can end up getting so quick at this, too. And, I mean, addition and multiplying, those are like some of the easier operations to do compared to dividing and stuff. So, subtracting, right? So, I mean, of the ones we have to pick from, it's not that bad. Not too shabby. All right, let's see. Bad news, though, now. Here we go. Here's the weakness of this method. Example. No, that's not an x at all. There we go. But bam, there's an example. So what if I've got 4x to the 4th minus 5x squared plus 2x plus 4. And now let's say I'm dividing this by 2x minus 1. Thoughts? Let's talk about this one before we write anything. Why?
Because the coefficient is 1.
Right, it's linear, so that's a check. It's a binomial, that's a check. But the coefficient, the leading coefficient's not 1. Well, I've got a solution for us. Yeah, let's make that a 1. Let's divide that by 2. And if I divide that by 2, then I got to divide this by. But if I divide this by 2, then I've got to divide this. So I might as well just go through and divide everybody by 2. So basically, I want that to be a 1 so bad, let's make it a 1, no matter how much it hurts everybody else.
So it can work for any thing, you just have to simplify it.
If this was like an x squared, there's nothing I could have done to fix it, unfortunately. Because yeah, I wouldn't. It would be hard. But as long as it's linear in a binomial, then yeah, you can still fix the coefficient piece. But yeah, so sometimes we can modify it. So let's see. Let's figure out what this is. So this would be 2x to the 4th minus 5 halves x squared plus 2 divided by 2 is 1x plus 4 divided by 2 is dose. And then I'll have divide by x minus a half. And now I can synthetically divide, even though we're crying on the inside because of these fractions, I know. So what's going to go in the box?
1/2.
Ooh, good catch. Positive 1/2 because
It's the
opposite day. Breathe, Patrick, breathe. Not that opposite. So let's see. Okay, what are my numbers?
2, 0.
Oh, he caught it. Then negative 5 halves, and then 1, and then 2. So this is going to be interesting, friends. All right, step 1. Add. 2 plus nothing is 2. By the way, the mistake that I made earlier in the other class, I added this column first, and I got a half, and then it got really ugly. So realize you're not doing the add the box column. You're adding your first non-box. Let's see. Multiply. 1/2 times 2.
1.
Half of 2 is 1. Okay, I like that. Add. 0 plus 1 is 1.
Wait, where did you choose from at first? Sorry. Oh, you
Just add it. Yep. You feel free to add those little arrows if you want, if it's going to help you for tonight. Let's see. Multiply. 1/2 times 1 is 1/2. Now let's see. Can you guys add this one here? Okay, so these had a common denominator. -5 plus 1 is -4 over 2. And -4 halves, -4 divided by 2 is -2. Okay, so that one worked out quite nicely, in fact. Let's see, multiply. 1/2 times -2. Half of -2 is? -1. Then we'll add. Multiply. Oh, I like multiplying by 0. It's the best. And then add. Whew. Let's see, can you guys translate this? Actually, I've got bad news. 2 is not going to be a remainder. Well, it's not going to be our remainder over this guy anyway, because remember I did this divide by 2? It turns out to find your remainder, you're going to have to re-multiply just that part by that 2. So if I originally divided everybody by 3, I'd be multiplying by 3 down here. All right, so that's kind of like just a sneaky little thing, so be aware of that. And it's only the remainder that it affects. All right. Let's see, 0 is my constant, so I don't have one of those. -2 is my x term, so -2x. 1x squared, it's positive. And then 2x to the what? Cubed. It's always one exponent higher than the one before it. So if I wanted to write this, I could write 2x cubed plus x squared minus 2x plus 4 over 2x minus 1. Okay? So that little remainder trick at the end kind of can be throwing you for a loop as well. So be careful of that, friends. Be careful. Oh, excellent. Well, all right, internet friends. Have a great day.